On the sixth day of math, Miss Mathner gave to me one simple proof. That's right, today is day 6 of 25 days of math miss, and today we're gonna go ahead and prove why the square root of 2 is irrational. And I know that a lot of people might think that this is very simple, and it actually is, but it's gonna lead us to something else that I can't quite reveal yet. But the proof is so historical. Archimedes actually talked about this, but it wasn't proven until Euclid's Elements. I mean, think about it. This was something that has been passed down from the ancient Greeks to today, and understanding how to prove it using contradiction is something that is very priceless. So we gotta prove that square root of 2 is irrational. Let's go ahead and talk about what that actually means. If a number is rational, then that means that it could be written as a fraction a over b, where a and b are integers and b cannot be 0 because otherwise you will have something that's undefined. Irrational doesn't fit that. So something like pi, e, maybe I mean, that's gonna be complex, but those numbers go on forever, meaning that you can't write them using a fraction, because a fraction will give you a finite number that is in a decimal form. Let me just give you an example. Let's just say 3/2. I mean, that's gonna be 1.5. Notice that it ends. This is what we call a finite decimal. But if it goes on forever, then there's no way for us to write that fraction, and that's what makes it irrational. So we're gonna go ahead and start off by using that idea. So we're gonna do this by contradiction, and we're gonna assume that square root of 2 is rational. In other words, we can go ahead and write square root of 2 as some fraction a over b, where once again, a and b are integers, b cannot be equal to 0. Maybe I could even write that a and b are integers, and then b cannot be 0. One other thing that we have to make sure that we understand is with a rational number, a and b are co-prime, meaning that the greatest common divisor between the two a and b is gonna be 1. But anyway, once again, guys, this a and b has to be co-prime. And that's gonna be really important, okay? Now, let's go ahead and get started with our proof. We're gonna go ahead and square everything so that we can go get rid of that square root. So we have 2 equals a squared over b squared. And let's go ahead and multiply the b squared to the other side. 2b squared is equal to a squared. All right, well that just tells me that a squared is equal to 2b squared. This is an even number, because remember, an even number is a multiple of 2, like 2, 4, 6, 8, and so on. So that tells me that a squared is gonna be even. Well, that would imply that a is also even, because if a squared is even, that means that the original value also has to be even. Because if somehow it was odd, when you square that, a squared should not be odd. Let me just give you an example real quick. So let's just say you have a value m, and it's, let's just say it is gonna be odd. This is the form that you use to say that it is odd, because it is not a multiple of 2 anymore, it's a multiple of 2, and then plus 1. So if you square this, m squared, you're gonna square this, and you're gonna use FOIL method and get 4k squared plus 4k plus 1. Now, this portion right here is divisible by 2. I can actually factor out a 2 from it and get, or I can factor out a 2k and get 2k plus 2 right here, plus 1. This is even plus a 1, that makes it odd. So a has to be even. Okay, that's interesting. Well, that means that a can be written as some value 2n. We square that, we get a squared is equal to 4n squared. So now I'm gonna go ahead and substitute this 4n squared into here. This is now gonna tell me that 2b squared is equal to 4n squared. Well, let's go ahead and divide the 2 to the other side, and we get that b squared is equal to 2n squared. Now, hold on, b squared is now even. And as we mentioned from our previous discussion, b should also be even. So we have b is even and a is even, but that doesn't make sense because a and b have to be co-prime. The greatest common divisor from a and b has to equal to 1. This can't happen. Square root of 2 can't be written as a rational number. Therefore, we say by contradiction, because that's exactly what we found, square root of 2 is irrational.